Today we'll be talking about segments and congruence. And to really talk about those topics, we need to understand distance. And I know you all know what distance is, how far something is away. I am 3 miles away from the school. That is your distance. Now, what this will look like geometrically, if we have point C, F, and say, okay, it's 12 centimeters. That's how it would look in a picture. To notate this, we would write CF equals 12 centimeters. Notice there is no bar. There is no bar up here when we talk about distances. That is how you can tell the difference between talking about the distance of CF or talking about the actual segment CF. So CF, this means segment. That's what we're referring to. And if we just have CF without the bar, that's your distance. Big, it's a subtle difference, but it means something completely different. Now we have something called the segment addition postulate, and I kind of call this the oh duh, that makes sense postulate. Basically, if we know that point B is between points A and C here, it means that the distance from A to C is made up of the distance from A to B plus the distance from B to C. Yeah, those two parts, the two smaller parts, you add them up, you get the whole thing. That's what the segment addition postulate says. So let's apply that down here. So if we look at this example, it says the location shown lie in a straight line. Find the distance from the starting point to the destination. So over here, we have from S to R, that is 64 miles. So SR equals 64 miles. Then we have RD, that is equal to 87 miles. And the whole distance from S to D, that's going to be SR plus RD. Now, you may be saying, I can just do this, I know to add them up and move on with life, and that is perfectly fine. You are allowed to do that. And after this example, I will be doing that. I just wanted to write this out so you could see where the math comes from. So SD is equal to 64 plus 87, which leaves us with SD is equal to 151 miles. Make sure you have your units. That's the most important part of this problem, is that your units are correct. All right, let's look at this next diagram. Now, this one is going to be a little bit backwards because we know that this whole length from J to L is 38. And we only have part of it from J to K as 15. So if we write it out as, JL equals JK plus KL, well, we know that JL is 38, and we know JK is 15. So then we can subtract 15 from both sides. And that will give us what just KL is, and that's going to be 23. So 23 equals KL. So we had to subtract in this one because we were given the whole measurement here. That was 38. Now, if we look at example 3 here, find QS and PQ. So this part from P to R is 55. From Q to R is 31. So if we want the length of PQ, we would just do 55, the whole thing, minus 31, and that gives us 24. So PQ is 24. And you can always double check. You can go in your calculator and say, okay, 24 plus 31, that is 55, which is what the original problem gave us. It's a good idea to double check that sometimes, especially when you're doing some complicated calculations. Now, the second part of the problem says, what is the length of PQ? Or sorry, no, QS. So from Q to S. Well, part of it's 31, the other part of it is 30. So QS is going to be 31 plus 30, or 61. There are no units in this problem, so we can leave our answer like that. And then we had PQ, that was 24 from our work back here. Another term that we're going to deal with is the term congruent. Congruent figures or congruent shapes have the same characteristics. And the way we draw that are with little tick marks. So if I have segments C, F, and segments A, D, if I want to show that these are congruent, we put tick marks on them. This tells us that CF and AD are congruent. When we talk about congruent, basically what we're going to use this mostly for is, same size or length. So CF and AD are the same length. Now, what if we were talking about some other segments? What if we had JK and segments RS? And these two segments were congruent, JK and RS, but they were not congruent to segments CF and AD. If we just put one tick mark here, what this is telling us is that all four of these segments are congruent. But that's not what I said. I said that CF and AD are congruent to each other, and that JK and RS are congruent to each other. So to show this, we would put two markings here. So now this picture shows that JK and RS are congruent to each other only, and that CF and AD are congruent to each other only, and that you can't say CF is congruent to JK. They have a different number of tick marks on it. So that is how you can differentiate between which segments are congruent to which ones. The notation for this, we would write that CF is congruent, and this is the congruent symbol. It's an equal sign with a little squiggly tilde over the top of it. So you say CF is congruent to AD. Notice that we have the bars here because we're talking about congruency. Segments, this is segment CF, this is segment AD. Segments are congruent to each other, as opposed to up here, the distances, we would say that they were equal. And then we have JK, segment JK is congruent to RS. To talk about if we're talking about, again, the distances or the lengths, we would say CF equals AD, and that JK equals RS. Notice we do not have the bars over these because we're talking about its length. Lengths are equal, segments are congruent. And that's what this says down here as well. If you ever forget, you can refer back to this. All right, in example 4, we're going to plot these points in the coordinate plane and determine whether segments FG and HG are congruent. Let's plot FG first. 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And negative 1, 5. So here's FG. And then we have H is at 3, 3. And J is at 3, negative 2. So how can we tell if they're congruent? Well, if they're the same length, that means they're also congruent. So we can count FG. Well, 1, 2, 3, 4, 5. So length of FG is 5. And the length of HJ is also 5 if you were to count. So yes, FG is congruent to HJ because they have the same length. Okay, in example 5, we have segment RT where RS is 4x minus 8, ST is 3x minus 10, and RT is 38. Solve for x and find the measure of each segment. We want to draw this first. So we're going to draw RT, and point S is somewhere between them. We don't know where. It doesn't say that it's in the middle, but it's somewhere in there. We know from R to T, this whole length is 38. We also know that RS is 4x minus 8. So RS is 4x minus 8. ST is 3x minus 10. So if we were to add these two parts up, 4x minus 8 and 3x minus 10, that needs to equal the whole thing, which is 38. So we have 4x minus 8 plus 3x minus 10. That equals 38. So then we would solve that. We have 7x minus 18 equals 38. And then we would add 18 to both sides. So 7x would equal 38 plus 18, 56. Divide both sides by 7, and x would equal 8. So we did that part. We found out what x is. The question, though, said find the measure of each segment. So now we got to plug x back in. So RS is going to be 4 times 8 minus 8. So that would be 24. And then ST is going to be 3 times 8 minus 10. And that's going to give us 14. Now we have the other parts of the problem solved. And what you should do is you should double check. We're told that the whole segment is 38 units long. Well, what is 24 plus 14? That is 38, which is what we were told originally. So this is just a way to double check to make sure that you did the problem correctly. If these two numbers didn't add up to 38, then you know you made a mistake somewhere. Either you made a mistake solving for x, or you made a mistake plugging this back in. All right, if we look at the next page, we're going to skip the construction for now. So that's the end of this lesson. Make sure you like the video and subscribe. Bye.